two locations are 60 miles from each other. There is a car going this way at 20 miles an hour, and there's a car going this way at 25 miles an hour. So I know that they're separated by 60 miles. So obviously, the car B is going to be, or the car that starts at B heading towards A is going to, what do you call it, drive a little bit more. So at the point where they meet, they will probably meet somewhere a little bit further to the left of the middle. So they meet somewhere over here. The question says how long before they get to that point and meet head to head, right? So let's create a table. Car A is traveling at 20 miles. Car B is traveling at 25 miles an hour. The time they drive for, I have no idea how long they drive before they meet. So that's just T. And same thing for car B. They drive for the same amount of time, by the way, of course, right? But the distance that they drive for, it's obviously different. So distance in this case for car A is right now it's called 20T. For car B is called 25T, right? Because distance is rate times time. What do I know about the distance of both two cars? I know that the distance of that car A will travel and the distance that car B will travel. If I combine those two distances, it will equal 60 miles. And that's my equation. So right now, the distance for car A is 20T. The distance for car B is 25T. Combine like terms, yeah, 45T equals 60. Divide both sides by 45 to isolate my variable. T in this case is going to be, if I simplify 4 over 3, or if you put it in terms of hours, 1 1/3, and then you can change that to what's 1/3 of an hour. If you take 60 minutes and divide it into thirds, it's going to be an hour and 20 minutes. All right, so 1 1/3 hours. You know, we can just leave it like this, or that, or this, or if you actually want the time, it's an hour and 20 minutes. Now, we're going to take that and plug it in here. So car A, so again, both cars drove for the same amount of time. And as far as, I'm going to write it 1 1/3 here and 1 1/3. So they both drove for 1 1/3 hours. Now, if you want to find the distance, just to check to see how far each car traveled. In this case, we're going to multiply 25 times T, but instead of 1 1/3, I'm going to use the improper fraction version. 25 times 4 is 100, divided by 3. If you change that to a mixed, mixed number, that would be 33 and 1/3. So car B drove for 33 and 1/3 miles. Car A, it's 20, and I'm going to use the improper fraction, 20 times 4 over 3, which is 80 over 3. Ugh. 80 over 3 is 380 divided 3 times 26. So 3 can go into 80 26 times, which is 78, and so we have 2 left over 3. So car B drove for 26 and 2/3 mile. Now, if you combine those two, distance of car A traveling, distance of car B traveling, you'll notice that it does equal 60. So, very good. But the question only asked for this, right? How far, for how long did both cars travel for? I need a chiropractor. My neck is killing me. 2 cars again, separated for 276 miles. Let's call this A and B. This one's a little bit that says the travel at rates differing by 5 miles per hour. So this is R. I guess we can call this R plus 5, right? Because there's a little faster. If they meet after 6 hours, find the rate of each. So again, they're going towards each other, right? They're eventually going to meet, and after 6 hours. So we know they drove for 6 hours before they met. In this case, what was the speed of each car, right? Okay, so A and B. R, T, and D. Car A travels don't know. Car B travels a little faster, R plus 5. The time that they both drive for is 6 hours. So now we can find the distance. So distance would be rate times time. In this case, R times 6 is 6R. The bottom one would be R plus 5 times 6. Do this through your property. And that's what you get. Set out of the equation, just like the previous problem, we know the distance the car 1 traveled, car A traveled, plus the distance car B traveled. It equals to 276 miles. 6R and 6R can be combined. Now we have a two-step equation. Subtract 30 from both sides. That goes away. 12R equals 246. You're going to divide that by 12 and divide that by 12. So R is equal to 20.5. And that's the speed of one car. So one car was traveling at 20.5 miles, and that's what it is, 20.5 miles. And the other cars, 20.5 times 5, 20.5 plus 5, so that his speed obviously is 5 miles faster. Okay. If you want to check, so car A travels, so again, let me put this, car A travels at 20.5 miles per hour. So if you multiply 20.5 times 6 hours, I don't know what you get, 20.5 times 6. You get that he traveled 123 miles. Car A drove 123 miles. Obviously, car B travels a difference of 276 minus 23, but let's just make sure. So car B, this is speed, right? So again, 25.5, and if you multiply that by 6, you get, no idea, 25.5, you multiply that by 6, you get 153 miles. So car B, who was a little faster, obviously covered more distance. And if you think about it, 123 plus 153 does indeed give you 276. So looks like we're good so far. 3. Again, another 2 trains, really, a lot of trains here. And this one, they're 195 miles apart. They travel at the rate, so it doesn't matter. There's one train going this way and the one train going this way. Just call it A and B. And this guy is 25 miles an hour. This guy's 45 miles an hour. If they start same time, how soon do they meet? All right, so again, their meeting point, I'm going to say it's going to be a little bit to the left of the middle, right? Because definitely train B is going to cover more distance. So again, set up our table. Train A is 25 miles an hour. Train B is 45. The time is what we want. So that's my, I don't know, RTD. So my distance right now, the distance of A would be the 25 times T. Distance of B is 45T. Again, I ask you to imagine this. What do I know about their distances? I know the distance covered by car A, represented by 25T, plus the distance covered by car B, represented by 45T, is going to equal 195. Combine like terms, we get 70T equals 195. We're going to divide both sides by 70. I hope that's some type of a pretty number. 195 divided by 70 equals, oh no. No. Let's see if we can simplify this a little bit. Right. Sorry guys. If we can simplify this, divide by, sorry guys, I'm trying to simplify that. Make it more manageable. So let's divide this by, if I divide this by 5, I get 39. If I divide the bottom by 5, I get 14. So time-wise, and if you look at time, this would be 2, which is 28. 14 goes 39, 2 times, which is 28, and 11 over 14. So that's the time. Yikes. I wonder if they, what is this question number 3? Oh, I see. Oh my God. Everyone, you must have, okay, so this is 40 miles an hour, so I have to redo the whole thing. I apologize. I put 45. Okay, that's probably, I'm getting some. So again, A and B. A is 25 miles an hour. B is 40, so that's the rate. The time is, I don't know how long they drove. until they met. And the distance right now we can, okay. The distance is rate times time. So for A, it'd be 25t. For B, it'd be 40t. Again, the distance covered by each car added together gives you 195 miles. So distance covered by car A, which is represented by 25t, plus distance covered by car B, which is represented by 40t right now. Combine like terms, we get 65t equals 195. Divide both sides by 65. And I have no idea what you get. So 195 divided by 65 gives you 3. So they meet after 3 hours. The time here is 3 hours, and the time here is 3 hours. Now, you want to figure out how much they drove for. 40 times t. Oops, 40 times 3, right? 40 times 3. So car B drove for 120 miles. Car A, if you do 25 times 3, you get 75. So it's 120 and plus 75, 195. Yeah, you're good. Sorry about that. Hopefully you caught the mistake. For A and B, this one, they're traveling towards each other. At each other at the same time from 150 miles apart. So they're 150 miles apart. If A went at 20 miles an hour and B, what rate must B travel if they meet in 5 hours? Okay. So B I don't know. So here's my table. A, B. Information given to me right now looks like this. The rate for A is 20 miles an hour. And the rate for B is what we're trying to find. So I'm going to write R. The time, time is 5 hours for both. At what rate must B travel if they are to meet in 5 hours? So how fast does train B have to be in order for them to meet in 5 hours? Well, the distance of A is 20 times 5, which is 100. The distance for B right now is R times 5, which is just 5R. So, and again, what do I know about their both distances? I know that the distance covered by train A, which is 100 miles. That makes sense, right? If you're traveling at 20 miles an hour and you drove that for 5 hours, you cover 100 miles. So, 100 plus 5R, which is the distance covered by train B, they have to equal 150 miles. Uh-oh. So, solve that equation, please. While I charge my laptop. Okay. So we have minus 150, minus 100 on both sides. This goes away. We get 5R equals 50. And divide both sides by 5. And R equals 25. So train B traveled at a rate of 25 miles an hour. Now, let's see if that works out, because I know train A, he traveled 100 miles an hour. 100 miles. Train B, did I do something wrong? Oh, yes, because I know what I did wrong. Sorry. Oh my God, show off, seriously. Dividing both sides by 5. Sorry, guys. That goes away. That goes away. Train is 10 miles an hour. Oh my God. So, train B travels 10 miles an hour. Now, in 5 hours. So again, if you do that for 5 hours, how far do you drive? Or how far? What's the distance that you covered? 50 miles. So, train B went for 50 miles. So let's just go like this. Train A did the bulk of the distance, and he traveled for 100 miles. And again, the distance that they covered together should add up to 150, and they do. Let's talk about mistakes. Sorry. Passenger and freight cars start towards each other at the same time from 300. So again, 300 miles apart. The rate of the passenger train exceeds the rate of the freight train by 15 miles. So let's call this passenger train, and that's going that way. And this is the freight train. So the by 15 miles an hour. So the freight trains, we don't know the speed. Okay, so we'll call it R. Passenger train's a little faster. It's whatever the freight train travels by plus 15. And they travel for 4 hours, right? They meet after 4 hours. So um, hopefully they're different tracks though. Passenger train, freight train. Let's call this the freight train. The passenger train, so RTMT, the passenger train is 15 miles faster than the freight train. The freight train travels at this speed right now, R miles an hour. So the passenger train would be that R plus 15. We're traveling for how long? 4 hours before they meet. So, and the distance we can find, that's easy. R times 4 is 4R. And over here we do the street property, we get 4R plus 60. So, we know that the distance covered by each train, this is the passenger train, plus the distance covered by the freight train will equal 300 when they meet. Now it's just solving, combine like terms, 8R plus 60 equals 300. Subtract 60 from each side. You get 8R equals 240. Divide both sides by 8, and R equals 30. So, now that I know R, that's the speed of the freight train. The speed of the freight train is 30 miles an hour. And the speed of the passenger train is that 30 plus 15, or 45 miles an hour. Yeah, that's it. So 40. That's what do we want? What must be the rate of each? Well, one train was 45 and the other 30. 6. Again, two autos going towards each other. Wow, a lot of this. Okay, sorry. This one's different. So car A and car B are back to back. But car B is going this way. Car A is going that way. Your rates are 25 miles and 35 miles. So this guy's traveling at 25 miles and this guy's traveling at 35 miles an hour. How many hours were they? After how many hours were they 180 miles apart? So at what point, okay, so let's say they travel, car A stops, car B travels, and stops. Sorry, car B travels over here, stops over here. Okay, and this distance is 100A. So at some point, car A travels and stops right here. Car B travels, stops right here. So what is the distance? Right there. They're 180 miles away from each other. So how long do they have to drive for to be 180 miles between each other? So A and B. A is traveling at 25 miles an hour. B is traveling at 35 miles an hour. The time we don't know, but the distance we do. So when we set the table, so the time is what I need to know. So that's T. It's going to be the same time for both. A, the distance is 25 times T, which is 25 times 25T. B is going to be 35 times T, which is 35T. So the distance that they both travel added together equals 180. And that's my equation. 25T plus 35T equals 180. What is that? 60T equals 180. Divide both sides by 60. And the time is 3 hours. So both cars travel for 3 hours. One has a speed of 25 miles an hour. The other one has a speed of 35 miles an hour. So let's see. If you travel 3 hours at 25 miles an hour, you're going to cover 75 miles in distance. The other car is driving at 35 miles an hour for 3 hours. And 35 times 3 means that in 3 hours he can cover 105 miles. Notice that if I combine these two, I get 180 miles between those two cars.